afternoon, everyone. This is the reporter of Group 7. And now let's discuss the Z-test definition. So, a Z-test is conducted on the population that follow a normal distribution with independent data points and has a sample size that is greater than or equal to 30. So it is used to check whether the means of the two populations are equal to each other. When the population variance is known, the null hypothesis of a Z-test can be rejected if the Z-test statistic is statistically significant when compared with the critical value. See, the Z-test formula compares the Z statistic with a Z critical value to test whether there is a difference in the means of the two populations. In hypothesis testing, the Z critical value divides the distribution graph into acceptance and rejections regions. If the test statistic falls in the rejection region, then the null hypothesis can be rejected, otherwise it cannot be rejected. The Z-test formula to set up the required hypothesis test for a one sample and a two sample Z-test are given below. So, one sample Z-test is used to check if there is a difference between the sample mean and the population mean. When the population standard deviation is known, the formula for the Z-test statistic is given as follows. So this is the formula of Z-test statistic. So it's the example mean. This one is the population mean. And this one is the population standard deviation, and the N naman is the sample size. Now, left-tailed test, a null hypothesis. This means is there is no significant difference between the population, and the population mean equals the population mean 0. And now there's a alternate hypothesis. This one is there is a significant difference between the population. So null hypothesis is there is no significance, and sa alternate hypothesis is there is a significance. So on the population mean, then greater than population mean 0. Now, in decision criteria, if the Z statistic greater Z critical value, then reject the null hypothesis. And now let's proceed to the right-tailed test. Now, null hypothesis, so the same. So there is no, and the alternate is there is. And so diri na pud sa sa alternate is kuan siya kanang sa less than siya. Diri sa kuan kay greater than. So decision criteria, if the Z statistic greater than Z critical value, then reject the null hypothesis. So that's all, everyone. Thank you.
Good afternoon, Mom. I am Riza Meroshana, and today I will be discussing the two-tailed test, which is the continuations of the report of Group 7 about the Z-test for mean, and also I am going to discuss about the formula and provide an example on how to solve using the formula of Z-test for mean. So let's proceed to the two-tailed test. So we have the null hypothesis. We have H0 is equal to the population mean, and alternate hypothesis, we have the H1 is equal to or greater than the population mean. And also, if the z statistic is greater than to the z critical value, then reject the null hypothesis. So today I will be giving an example on how to solve or on how to use the formula of z-test for mean. So I have here an example. So let's read. A teacher claims that the mean score of students in his class is greater than 82 with a standard deviation of 20. If a sample of 81 students was selected with a mean score of 90, then check if there is enough evidence to support this claim at 0.05 significance level. So today I have here solutions, which is step 1. We need to state the null hypothesis. So we have here the null hypothesis, which is at 82, which is the population mean. We have 82 is the population mean. So we will write here hypothesis is equal to population mean, which is 82. And then step 2 is atong state ng alternative hypothesis, which is the H1 is equal to or greater than 82. So from the Z table, the critical value at area is equals to 1.645. Muna siya ang kanang value sa area sa Z table. And then, let's solve this problem using the formula of z-test for mean. Okay, let's solve the problem using the z-test formula for mean. So we have a formula here. We have z equals to sample mean minus the population mean over standard deviation divided by the square root of sample size. So naa naman tayo mga given dire. So atuan na lang ni siyang i-solve. So first we have, okay, the sample mean we have 90. So i-minus nato siya sa population mean which is 82. So we have 90 minus 82. So over. So atong standard deviation is 20. So 20 divided by the square root of sample size, which is 81. So 20 divided by the square root of 81. So then next, atoa siyang i-minus ang 90 minus 82, which is 8, over ang 20. I-copy nato siya, kaya ito sa square root ang 81. So 20 divided by, so 8, square root of 81 is equal to 9. So next, we have, copy na to ang 8, and then ang 20, i-divide siya sa 9, which is 2.22. And then, our total, or our z, is equals to 3.60. So, this is the final answer. So, as 3.60 is greater than 1.645, thus, the null hypothesis is rejected, and it is concluded that there is enough evidence to support the teacher claim. So the answer is we reject the null hypothesis. So we will write null hypothesis. So let's draw here kanang ka-align. Na. Then mo din siya ang median, right? Then diri siya ang right side, mo diri ang left side. So kaya atong ang kuan kay man siya kanang i-reject na tong null hypothesis. So this is an example of right tail test. So diri is estimated na to, so i-shade na to ni siya, reject na siya diri. So that's all. Thank you.
So, good morning everyone. This is Shara Glasses, and I will discuss about right tail. I will discuss about right tail test. So, null hypothesis, or HO, and mu equals mu0, and alternate hypothesis H1 when mu less than HO, and decision criteria if the Z statistic is greater than or less than z, critical value then reject the null hypothesis. Then when we have the two-tailed test, their null hypothesis HO, then the mu equals mu0 and alternate hypothesis equals H1 and mu then mu0 and decision criteria, and the z statistic is less than z critical value then reject the null hypothesis. So dire ipakita nga ang right tail test igamit kung gusto nato makita kung mas dako ba ang sample mean kaysa sa population mean. And then, diri sa H2, diri makita ang pareho ang mean. And then, diri naman sa H1, diri makita ang mas dako ang sample mean. Kung sa Z statistics, diri makita ang critical value and diri na to ma-reject ang HO or ang kani siya nga value. Pasabot ang significant, mas dako ang sample mean niya sa right-tailed test. Diri naman sa two-tailed test, ano siya igamit kung gusto na to mahibalan, kung gusto or kung lahi ba jud ang sample mean sa possible or kung lahi ba jud sa population mean, pwede siya mas taas o mas ubos ang kaning two-tailed test. Then, ang kaning HO, muna siya ang pareho ra ang mean nila. And then, kanay H1 is muna siya ang lahi nga mean. And then, kung ang Z statistical is mas dako ang value, is i-reject na to ang HO, kanay-ana na to, or kanay-ana na to, and then, ang kalainan ana is naay duha ka mean. Pasabot na siya duha ka mean ani. Yung dire kay ang pasabot dire is ano siya kanang sample mean and tapos siya sample mean and dire is duha siya ka sample mean. And then natay usa ka example which is sample number 1. A teacher claims that the mean score of students in his class is greater than 82 with a standard deviation of 20. If a sample of 81 students was selected with a mean score of 90, then check if there is enough evidence to support this claim at a 0.05 significance level. So this is the solution. As the simple mean size is 81 and population standard deviation is known, this is a sample of a right-tailed one sample test. So this is the solution. HO equals mu equals 82. H1 equals mu greater than 82. From the Z table, the critical value at A equals 1.647. So this is the critical value. And Z equals X minus mu over 0 over N. Then X equals 90, so the N equals 82 and equals 81 equals 20. And then, as 3.6 less than or greater than 1.645, thus the null hypothesis is rejected and it is concluded that there is enough evidence to support the teacher's claim. So the answer of this solution, for example, is what we call reject the null hypothesis. So this means that ang usa ka maestro nag-ingon siya nga mas dako ang 82 average score sa iyahang mga estudyante, which is ang given population mean is 82 and then the sample mean is 90. The standard deviation is 20 while the sample size is 81. Then Z equals
o ang critical value niya is 1.645. Then ang tungod kay 3.6 man greater than 1.645, gi-reject siya ang null hypothesis, which means in conclusion naiigo nga evidence nga ang average score sa klase mas dako jud siya ang 82. Mauni ang sakto, muna siya ang pagsakto nga pag-claim si teacher, which is ngayon siya nga mas dako ang 82%.
Good afternoon, everyone. I'm Ronel IBG Masweto, and I will be reporting the 2 sample C test. So, what is the 2 sample C test? A 2 sample C test is used to check if there is difference between the means of 2 samples. The C test statistic formula is given as follows. So, this is the formula of the 2 sample C test. So, C equals x1 minus x2, which is the sample means, minus n1 minus n2, which is the sample sizes. Sample means, sample sizes over 1, 0 to 1 plus 0 to 2, which is the population variances over the hypothesized difference n1 plus n2. So, I have here some example of a 2 sample C test. A researcher wants to check if the average score in science of section A is different from section B. Section A has 50 students with a sample mean score of 78 and a population standard deviation of 8. Section B has 60 students with a sample mean score of 74 and a population standard deviation of 7. Use a 0.05 level of significance. Is there any significant difference between the 2 sections? Our solution, since we are comparing 2 sample means and the population standard deviation are known, we use the 2 sample C test. So, what are we going to do? First, we're going to copy the sample. We're going to use the formula. First, we are going to find the sample means. Our sample means is Our sample means is 78 and 74, followed by sample sizes of 8 and 7, followed by the hypothesized difference between population, which is the 50 and 60. So, C equals 78, which is the sample means. This time we're going to use the formula minus 74 minus 0 over 8 squared plus 7 squared, which is the population variances here, and then over 50 and 60, which is the hypothesize. So, Z equals 8 times 8 times 8. 8 times 8 equals 64 over 50. 7 times 7, 49 over 60. So, plus, and din na to gikuha ang 4. 78 minus 74 equals 4. So, Z equals 4, copy the 4, and then 64 plus 49. 4 which is the 78 minus 74 equals 4. And then 8 times 8, 64. 7 times 7, 49 over 50. Copy the 50, copy the 60. So copy the 4, and then we're going to divide the 64 divided by 50. So 64 divided by 50 equals 1.28 plus 49 divided by 60 equals 0.8167. So we're going to plus this. Copy the 4. Z equals 4 over plus 1.26 plus 0.8167 equals 2.0967. So what are we going to do with this? 4 divided by 2.0967 equals 1.907. So this is our final answer.
Good afternoon everyone, I am Elgin, and today I will be discussing about the rejection region of a chord line. So first, let us define what is rejection region. So it is a set of all values of the test statistic that causes us to reject the null hypothesis. So causes us to reject the null hypothesis. And then we have here the non-rejection region, or it is also called acceptance region. It is a set of all values of the test statistic that causes us to fail to reject the null hypothesis. So causes us to fail to reject. So ang rejection region, if to reject the null hypothesis, here naman sa non-rejection region, it is causes us to fail to reject the null hypothesis. Now we have like also critical value, or it is a point or boundary on test distribution that is compared to the test statistic to determine if the null hypothesis will be rejected. So later in a normal curve, I will show you which part is the rejection region, non-rejection region, or our acceptance region, and where our critical value wherein nato ang gamiton to determine if the null hypothesis will be rejected or not. So I have here a graph or normal curve. So first we have, so we all know that there is one tailed lang. It's either greater than or less than na sign na atong gamiton. But if less than or if left tailed, so atong gamiton nga sign dira kay less than. So here, so as you can see, so this is our normal curve. So this one is our critical value. So this one is our critical value. So from here to there, it is the acceptance region or our non-rejected region. So do not reject this. But this one, as you can see here, we have reject or do not reject. So our critical value, we will gonna reject this one. So from here, then naka-bold. Now, if right-tailed naman, sa normal curve natin, no, we will use a greater than the sign or symbol. Now, this is our acceptance region from here to here, and this one will be our critical value. So, if one tail. But if two tail naman, so we have here, no, critical value, and so atong gamitin na sign is equal. So, equal siya. So, left hand, we will use this sign. This one naman, we will use this sign. And then sa two tail, we will use this sign. So, as you can see. So, now, this is the illustration of rejection of null hypothesis. So, as you can see, kung left-tailed siya, there is a left na tumakita na yung critical value. No? It is the midpoint or the boundary. So, we have here also in the right-tailed, and if two-tailed, so both edges niya is critical values. The important notes on Z-test. So we have Z-test, that is a statistical test that is conducted on normally distributed data to check if there is difference in means of two data sets. So the sample size should be greater than 30 and the population variance must be known to perform a z-test or z-test. So the one sample z-test checks if there is a difference in the sample and the population unit. So the one sample z-test checks if there is a difference in the sample and the population unit. While the two sample z-test checks if the means, okay, two sample z-test checks if the means of the two different groups are equal. So one sample z-test want to check siya if if also difference between the sample and the population unit. And if we use two sample z-test, it will check the mean of two different groups if they were equal. So that's it.